Jeg ved, at det er meget vigtigt for Johannes, at vi skandinaver naturligvis forstår hinandens sprog. Men jag pratar en särskild svensk dialekt som heter hemsk svensk. So we're going to do this in English for the benefit of everybody involved. Hi guys, my name is Mikkel Johansen. I'm from Denmark. I have lived and worked in Colorado in the States for 5 years, where I learned American-style timber framing. I had a company called Timber Solutions for about 13 years. After the financial crisis, it stopped being fun and the company went down in flames. Right now I teach at a school pretty much like this, not quite as beautiful, but same situation. And Timber Solutions, or timber framing in Denmark, is slowly sort of coming up again. I have a few interesting projects on the drawing board. I'm going to show you some pictures of how we did it and some of the houses that we've built and the structures. We'll see if I can follow this itinerary, but we'll see how it goes. The previous presenters are a hard act to follow, but I'll see. I might repeat some of their statements. An American timber frame. This is actually in oak, and it'll be the only oak frame you'll see in this presentation. I do most of my stuff in Douglas fir, softwood. But then the next couple of pictures are the essential of what Timber Solutions do and what we explain to people in Denmark. Because people say, what do you put between the posts? And then you have to start explaining and explaining and explaining, and finally you show them, and they say, why didn't you say so? We erect a big frame, traditionally pegged together, except that in America everything is bigger, so the span between the posts are bigger, all the dimensions are bigger. The houses are a lot bigger over there. And then in the end you can't see the woodwork, so why bother? Except when you get inside and say, oh, why didn't you say so? And the beauty of this system, as you all know by now, because you've seen the other presentations, that instead of putting stuff between the posts, we put a skin around the skeleton, and the structural skeleton is protected from the weather by being inside, which makes a lot of sense when you think about it. You can change the wall system. I've had one of my houses actually got flooded. There was about 30 centimeters of water in the living room and outside. And it was a straw bale house. So he took off all the walls, and he had this spider with a beautiful roof and a first story, and pulled tarps from the eaves and out, and then rebuilt everything with a slightly different wall system. Why it flooded? Climate change. You heard about that? Yeah. And bad county planning. Unlike Rupert Newman, we do use a layout system called square rule. Rupert's system takes a huge amount of space and a lot of moving really heavy timbers around. These are a lot less heavy, and we don't move them that much around. Here, this is an exceedingly complex project, so it was pre-assembled in the workshop, and it's a fantastic project which shows what happens when you have a client who has way too much money, and he thinks he knows what he's doing. So we got to build it by the hour, not on a fixed price. We just go ahead and 1,100 square meters of residence for 4 people. And the architect didn't really know what was going on. And I think I'm an architect, so I just threw in timbers. On the workshop, this is why I don't have a forklift. You had a little timber tote with pretty fat tires moving things around. These are fantastic for moving timbers around on the same height as your sawhorses. And square rule layout works when you use Douglas fir, this red stuff, the softwood, and square rule, where you lay out and you cut each joint separate from all the other pieces. So it's one big jigsaw puzzle. And when you've done it a few times, you really don't need to pre-fit. You know when to cheat, you know, can make it very tight, and you can pre-cut. It's great for workshops because I can have one guy cut one post and another guy cut the plate, and the mortise and the tenon will fit together on site when you've done it a few times. So the timbers come rolling in on that little timber tote on horses. You get a drawing of each individual piece, and you cut that piece, and then they roll out in the other end of the workshop onto the truck and get shipped out to the site. And it works every time. That one got assembled. This is a double trusses on the great room. That's the living room. When it's above 100 square meters, it's called a great room. And for you engineers, this is really just a rafter and a tie rod across. It's really just a triangle. All the rest is just fluff. But it was made by the hour. Who needs it? What do you need a timber frame for? You don't need timber frames. You want timber frames. And he wanted a lot of wood. So, you know, all right, we can do that. This is a spline joint that it's not common, it's not existent in, at least in the Danish carpenter vocabulary. I doubt if it is in Swedish timber vocabulary either. The beauty of it is you got a post, you got two plates coming in, and you need to make mortises and peg holes and everything, and the poor post gets completely punched through. So you need more wood, bigger timber. And Douglas fir is beautifully straight, long, relatively inexpensive, but it splits real easy. That's the drawback of Douglas fir. So tenons tend to split and they can get pulled out. That's when I start using the different properties of the different species of wood. This, like most other things, is probably invented in China. It's common in Japan, then it came to the US West Coast and spread out from there, and I'm trying to bring it to Europe. There's a board of wood that's pulled through a hole in the post, and then there's pegs out here. So suddenly we can make the joint and all the forces are spread out to where there is enough of this relatively weak Douglas fir in front of the peg, and there doesn't have to be that much of the other wood behind the peg, and they match out the two strength properties. The best piece of wood I've found so far is elm. Elm grows one way one year, and the next year it grows the other way around, and then this way, and then that way. So the fibers of elm are sort of woven together. It's a bitch to split with an axe. It's relatively difficult to get hand of right now, so the next best choice is oak. Oak planks. Oak is good for this. And then again, you enhance it and you pull it down. I mean, this could be a piece of plywood, and if we put it up there, nobody would ever notice. But, you know, might as well enhance it and give the client something to look at and play with, and we can show off our beautiful work. But that through spline is a great joint, and the engineers like it. They can start calculating and make safety assumptions and so on. More splines, more spreading out joints, more enhancing what we like to do and what we're good at. This is in the lady of that huge house collects Spanish purebred horses, which is the most expensive part of the whole project. So this is the horse barn. But again, the king post with struts going out to 4 valleys and splines cutting through. It's a whole Christmas tree of showing off carpentry. Another horse barn, actually it's probably just a way to get rid of money. He had like 3 little horses over in a corner, and the rest of the building is filled up with 4-wheel drives and expensive office space and stuff like that. Douglas fir, again. And there was a question, what's the connection between the engineer and the framer? I have, and I'll get the website to you guys, a really, really good Danish structural engineer that I worked with several times, trained him to this little game of green wood and wooden pegs and so on. And he called me and said, that joint is not strong enough. That's about 40 centimeters by 20, and that's 30 by 20 centimeters. Those 3 pegs can't take it. You're going to do something about that. So he let me do the solution, come up with a solution. He told me what was wrong with it. So he actually suggested that I threw in a steel plate in the middle and then put 18 steel pins on each side. That's an engineering or a glue lamp German kind of solution. We can't do that in handcrafted woodworking. So I came up with 3 different solutions. Maybe we can put a post over here, we can beef that up, we can do this, we can do that. And I sent it back to the engineer. I said, I have 3 different ways that would work for me, because I know where the walls go or what kind of tools and materials we have to work with. And he discarded a few of them and said, no, that's not going to work, and do you really want to look at that? But you can that one would work, as long as you give me, what did he have, 30 millimeters here and 30 millimeters there, and it's 200 millimeters wide. And then we have a bolt going through. I think we have another one going up there. And they're plugged and hidden and discrete, a metal steel rod. So we just went out in the scrap pile and find a piece and cut it out and threw them in, and they're there and they're there. And it's a beautiful little feature. So that's an example of how to interact with your engineer. I'm pretty good at guessing decision dimensions. I send it to the engineer. He hopefully says, yep, that'll hold. Or sometimes he writes back and says, it's about 10 times stronger than it has to be. That's fine. I mean, use more wood. Or he says, what's wrong with it? It'll pull apart, or it's not big enough, or do you really want to put that post right in the middle of that beam? Can't we move it over or something like that? And then there's a little bit of going back and forth. But he's really good. He's worked in Sweden. I think there are 12 people in the company, and he wouldn't have a problem doing green softwood timber frame calculations. And he sends a huge report to the county that you can send on to the authorities, and they fit right in and say, okay, that looks authoritative, and they believe it. And I've learned to read between the lines, and down in the little corner here it says that 8.6 is bigger than 4.5. Good, it's plenty strong, we can go build. That's all I need to know. All the middle calculations, they're just to show off to the authorities. Walls. It seems so obvious that now we have erected this huge timber frame with a crane, and the crane is there, the guys are there, the scaffolding is there. Let's pre-make some walls and set it up the day after. And I was never able. We tried once to build our own panels in our workshop, and we ended up trying to flip over a 3 by 4 meter, 250 kilo. It got ugly. So we gave up on trying to make our own. There are a couple of companies in Denmark that make houses with pre-made panels, but they have their own systems. I know in Sweden it's more common that you have off-site prefab houses than you have on-site housing. That's the fancy housing. We're not quite there yet in Denmark. I was not able to find a company in Denmark that would accommodate their panel system to our frames. And then there is SIPs with using foam and Rockwool is a Danish company. Rockwool is a huge company. Do you know who funded the insulation value calculation law in Denmark? And you know what it says? That it's a really good idea to use a really lot of rock wool. They actually highly recommend that you put 60 centimeters of rock wool in the roof in Denmark. And it says recommend, and everybody thinks it's by law. SIPs are non-existent. So I don't have any solutions to walls on panels, but we have built a few straw bale houses. And that's where the frame comes in really handy, because it gives the straw bale wall something to lean up against. And I'm sure, where is she? Where are you? You will talk more about this tomorrow, and it'll be great. But here's my little contribution to it. The timber frame is wrapped in brown paper, enforced with fiberglass. I think you can get something. You must be able to get something like that here. Because when they spray or plaster the inside of the straw bales with clay or lime or whatever they use, it messes up the timber tremendously, so they need to wrap it up. So we decided on this frame to wrap it up back of the shop. And it made a lot of sense, because then they don't get dirty during transportation and erection. And you cut open and find the joint and so on. It's a bit messy, but some things it makes a lot of sense. And one of the things that I learned, and you might as well, instead of learning from your mistake, learn from my mistakes. When you wrap these, you just fold it over and tape it and staple it on the top side. What happens is when you raise the frame, and in Denmark it rains a lot, you get rainwater coming into the wrapping. And if it's open on the top, the rain comes in and you have this pond, reservoir of water right underneath there. So we run around and cut open with knives, and all the water's running into kids. Don't go there. Turn it around and staple it on the bottom side. It makes a lot more sense. But wrapping things ahead of time in the workshop is worth it. It makes life easier for the plastering guys. And the straw bale guy want to put 50 millimeters of clay plaster on the inside and then a lime plaster on the outside, because clay is at least 5 times tighter, less vapor, less permeable than the lime on the outside, as it has to be. And he want the clay barrier to be continuous around the frame. So we put 50 millimeter blocks, so he has a space that he can put his clay plaster behind. And there's little holes in the blocks, so the straw bales are tied on to the frame with strapping. That's one way to do a wall. The rare occasion when we got to finish a house, as much as we could, we did site-built wall systems. This is a workshop, actually, tiny little house. My experience with square rule, softwood, timber frames is 8 to 10 guys can build a frame of 40, 50 square meters in 6 days in a workshop. That's the going rate. And it comes out on a fairly simple frame. Don't try to do hips and valleys in entry-level workshops. Is 1 man, 1 piece of timber per day. So there's 10 people cutting for 5 days. Each guy gets to cut 5 pieces of timber, and there's 10 of them. That's 50 pieces of timber in the frame. And you can start counting. 1, 2, 3, 4, 5, 6, 7, 8. When are we done? How big a frame can we build in a 1 week workshop? It comes out remarkably accurate. I think it was Ben Broomgraber of the Timber Framers Guild who said, if all posts in corners and along walls are really just expensive wallpaper, move the posts into the room so people can walk around them and bang their heads into them and stuff like that. It becomes more prominent in the architecture. So I try to, there's not a corner post here. It's moved in, and it actually supports the purlin, and play with architecture, play with the structure, and so on. A site-built wall, I always end up training the carpenters doing it, because they have their way of building a wall, and here there's all these timbers in the way for their getting around it. What we do is I think that one shows it better. This one has plywood hanging from the timbers, and on top of the rafters there is battens nailed on per 30 centimeters. And you can use it as ladders as you climb up the roof. And it makes sense to have rafters for every 3-4 meters, 3.5 meters. And then you put the vapor barrier over that. And you put the vapor barrier around the plywood. And suddenly the house is closed in for the weather, and you can do the blower door test by that time. Check if you've done it right. And then on top of the plastic, you put the rafters. And outside the plastic, you put the studs. And you can have one guy starting to do all the insulation on the outside. And there's a little, as you said, a gap where the gypsum board, the drywall, slides right in behind the timber. So the timber shrinks along the plywood or along the gypsum instead of away from the gypsum. And do not try to caulk that gap. Then it'll just split. Just let it slide along. Works out really nice. And some people want, I've experienced that as well, they want a wider gap. So they have that little shade and it looks like the timber frame is floating. Looks really nice. Some people ask if they can get lighting in there behind the post. And you can play with that gap one way or another. It doesn't have to be a full fat timber frame. This is a perfectly beautiful example of just scrounging some. This is one of my guys at the workshop. Scrounged some leftover timbers, made some beautiful trusses, and got on with his life where he can sit and enjoy life instead of working all the time in his summer house. A very modern summer house where the client, who was an architect, wanted an oak plate with visible posts on the outside, and he also wanted the timber frame to be visible on the inside. But instead of getting an oak timber about that big, we had two separate timbers and put insulation in between it. It looks cool. And no braces. He's a modern architect. He's contemporary. Can't do braces then. Another, this is Douglas fir, but painted black. And make a black kitchen and black trim. And it becomes very stark and contemporary, or it gives a pretty cool look. Clients. My experience is that there was like 3 groups of clients, of projects. We had good clients that were very, very wealthy, and they wanted something that the neighbor doesn't have. So, and you can make good money and make beautiful projects by working with these super rich people. Just remember, they didn't get rich by being nice, so why should they be nice to you? But if you're willing to play that game with lawyers and so on, you can do some amazing work. The other kind of clients are the eco-builders. They don't have a lot of money. They want in on the project. So if you can work out some sort of deal on having them work with you, they're happy. And they're really good at paying bills. As when you've worked out all the kinks, they say, okay, yep, and they agree. I have had wonderful projects and times with straw bales and eco-builders and co-work, where they work along us. The really hard part is that well-established middle class who say, okay, now we want the great summer house or our final home, because how much of that timber frame thing do they really need? I could buy a new car for that money or a better kitchen for that money, and they could. So that's, in my experience, it's a very difficult market to get into. You probably solved it better. You have more capacity and a better system rolling. But getting into funky stuff like this is lots of fun. And you can be a great carpenter, and they're a lot easier. There's no vapor barriers and very little building codes, and you don't have to deal with tiles and the color of the carpet and so on. You can just be a carpenter. And they're fun to build. And this was actually I think that was 2011 or something, the final project that before I got out of. This is the project that got me out of the hole after the financial crisis. It's a lookout tower in Aarhus, the Botanical Garden. They were getting a new biodome with palm trees and jungle and butterflies, and they wanted a lookout tower inside. So you can get up and look into the canopy. And you take an octagonal foundation, make an octagon, then you take 8 huge Douglas logs and set them up like that, and then another 8 that you set up like this. And you get this cooling tower from a nuclear power plant, or whatever it looks like, and bolt it together and do a spiral staircase. And before that, by the way, the architect says, I want the whole thing tilting 7 degrees. So we had to do a spiral staircase that sort of tilts. It worked out. But getting the whole thing to fit together there is, and bolting them together, find out where they bolt on, was a geometrical challenge, which I really like. And I had specifically said in the contract, we have to build this before they set up the dome. So when we arrived with the timber, the dome was there already. But it's produced off-site. There are some scarfs, I think you can see one of them. It's sort of cut flat along the timber. On every place there, and there, all the way along, on all of them. And how do you cut that when they don't have the same dimension? They look straight, but they really aren't. And they're not perfect. How can you cut that? Well, it's all modeled up in 3D in AutoCAD. And all the inside ones are actually identical, and all the outside ones are identical. So I had to make 8 going one way and 8 going the other way. And from the AutoCAD model, we said, all right, it has a center line. And that flat has to be a specific distance from center and out. So instead of working from the surface and in with square timbers, we worked from the center and out, regardless of how fat the timber is and regardless of what it looks like. So what we need to do is establish a plane at a certain distance from center, and then at a certain height, or measured from the bottom of the timber and all the way up. And we came up with this system. You know, they're identical, they're level, and you pull a string, tighten it up, pull it into whatever thickness of the log, and then eyesight it. Eyesight is remarkably accurate. And he can shoot in with a stick and make a little tick mark there, and I can guide him up and down. I can guide him. He has to hold his stick parallel to that line. And it's accurate within 2 millimeters. That's pretty good for a log that's wobbling around. And we can press it back in and so on. So he makes a tick mark here, another one there, and one on the other side, one on the other side, and then we can cut that flat out with a chainsaw and brush it down and make it pretty. And then came raising day, and at some point we had 3 of those lifts and a huge crane. I mean, I'm sure that crane guy had a side job as a locksmith or something. He was so good. And every time we were getting ready to hoist another one in, it looks wrong. It looks wrong. It can't be. I got it wrong. I got it wrong. And it fit. It all fit. Came together real nice. There's a famous photo of these skyscraper guys in New York having lunch, and we wanted to do that. Except we're tied in. We're chickens on that one. That was it. Any questions? I can keep talking. I'm a school teacher.